All right, topic E is applications of trigonometry in right triangles. So now you know how to solve problems that require trigonometry in right triangles. We're going to apply them to real life scenarios. But the first thing that you need to do is you need to understand what an angle of elevation is and what an angle of depression is. So in your right triangle right here, this right here is your right angle. This angle right here is what is called your angle of elevation. Now, you would assume that it might be the angle that's on the top. But the reason why this is not the angle of elevation, the one on the top, is because this is where you are elevating from. You are starting here and you're going up. So this angle right here is called your angle of elevation. Now, the angle of depression is the angle, here's your right triangle again. You would assume that it would be right in this area right here, that this would be the angle of depression, but actually this is neither the angle of elevation nor the angle of depression. The angle of depression is actually this angle right here. So this right here is called the angle of depression. All right, so it's this angle right here. So this angle is called your angle of depression. One thing that you need to understand is that your angle of elevation and your angle of depression are equal to each other because they are alternate interior angles. You've got two parallel lines right here. Here's one parallel line right here. Here's the other parallel line down here on the bottom. And then here's your transversal. So your angle of depression and your angle of elevation are equal. So these two angles are going to always be equal to each other. All right. So let's look at question number 1. Question number 1 says the angle of elevation from a point 25 feet from the base of a tree on level ground to the top of the tree is 31 degrees. Calculate the height of the tree to the nearest hundredth of a foot. So this isn't bad if you draw the picture. Here's my picture of my situation. Here is the tree. So this right here is going to be my tree, okay? It's on level ground. So here's my level ground. And it says that the angle of elevation from a point 25 feet from the base of the tree. So this right here is your base. Here's my angle of elevation. It says that the angle of elevation from this point to the base, that's 25 feet away, so I'm going to label this as 25, is 31 degrees. All right, and then it asks you to calculate the height. So how high up is the tree? So I know right here that this angle right here is my angle of elevation. This side is the opposite to my angle of elevation, and this side is the adjacent. So using sine, cosine, or tangent, we know that tangent is the opposite over the adjacent. So I'm going to say that the tangent of 31 degrees is equal to x over 25. Now, in order to solve for x, all I have to do is multiply both sides by 25. Cancels out. So then all I have to do is type into my calculator, literally 25 times tan 31 equals x. And then it says rounded to the nearest hundredth of a foot, you get approximately 15.02 feet. Okay. All right, let's look at number 2. A man at the top of a hill. So let's draw a picture of it right away. Here's my man. He's at the top of a hill. So here's my hill. Looks down at a village in the valley. So this point right here is my village in the valley. The hill is known to be 30 meters in height. So I'm going to label this right here as 30 meters. And the man measures the angle of depression to be 25 degrees from the top of the hill. So right here, I know that this angle right here is 25 degrees. But remember, this angle is congruent to this angle, so I can label this as well as 25 degrees. Find the direct distance between the man and the village. So if the man is here and the village is here, this is my direct distance, so this is what I'm trying to figure out. Okay, so I know my angle. I know that this 30 right here is opposite, and I know this x right here is the hypotenuse. So I'm going to use sine. So I'm going to say that sine of 25 degrees is equal to 30 over x. Now, to get rid of that x in this denominator right here, what I need to do is I need to multiply both sides by x. So I get x times sine of 25 equals 30. Now, multiplying by x helps me get the x out of the denominator, but it doesn't necessarily help me get the x by itself yet. So in order to get the x by itself, I have to divide both sides by sine of 25. So I get x equals 30 divided by sine of 25, which is approximately equal to, you literally type that in right into your calculator, and you will end up getting that the answer is about, rounded to the nearest meter, 71 meters. Okay, let's try number 3 now. From a point P on the ground, so I'm going to draw my ground. There's a point P right here. The base of the tower, so here's the base, here's my tower, is 173 feet away. If the tower is 100 feet high, what is the angle of elevation? So this time I need to figure out what the angle is. How big is this angle? Well, I know that this is the opposite, and I know that this is the adjacent. So I know for a fact that I have to use tangent. So tangent of x is equal to, oops, sorry about that, this is 100, not 10, is equal to 100 over 173. Now remember, we talked about this many times, this tangent of x does not mean tangent times x. So what I'm going to do, to get this x out of here, I have to do the inverse tangent. So I'm going to say x equals inverse tangent of 100 over 173. Don't forget, to be able to do this, you have to press the trig button, which is right underneath the control button and to the right. Okay, so it's right next to the equals button. You're going to choose tan to the -1 of 100 over 173, and you end up getting, rounded to the nearest degree, 30 degrees. So that will be what my angle of elevation is going to be. All right, last one. Number 4, last question that we have to look at for all your videos today. One method that meteorologists use to find the height of a layer of clouds above the ground is to shine a bright spotlight directly up into the cloud layer and measure the angle of elevation from a known distance away. In the diagram below, the angle of elevation from the measurement station to the cloud layer is 64 degrees. So I know that I can label this angle right inside of here as 64. Okay. While the distance between the measurement station and the spotlight is 525 meters. So here's my measurement station, here's my spotlight. That means that this is 525 meters. And then it asks to find the height of the cloud layer, which is just the vertical distance when it asks you to find the height, which is x. So this is the opposite, this is the adjacent. So that means that I have to use the tangent. So the tangent of 64 is equal to x over 525. Multiply both sides by 525. Type this into your calculator exactly how you see it. You end up getting x is approximately equal to, rounded to the nearest meter. I need to type this into my calculator. 525 times the tangent of 64. And you end up getting approximately 1,076 meters. Don't forget to compile a list of questions you might have for me to ask me tomorrow in class. It's crucial that you ask me so you can get all the help that you need. All right, hopefully this stuff made sense to you. I will see you tomorrow.